making sure you guys understand that why we go through and solve quadratics using factoring. There will be some of you that are tempted to use shortcuts. You like to use your calculator. You see, like it was pointed out last period, hey, the answer is right here, and you don't even have to factor. Well, true. However, if you don't factor now, you might make it through chapter 5, okay? You might, at least parts of it. You will struggle with chapter 8 mightily because you factor to reduce equations or reduce fractions then. And chapter 9 you'll struggle quite a bit because you have the words sine, cosine, and tangent in your functions when you're factoring. So if you choose to not do it the way I'm telling you now, then when you get to later in the year and you can't factor, that will be on you. And I will tell you, you have to go back and watch all the stuff from chapter 5 again to learn to factor. Because I have students that will come to me and go, I don't know how to factor. Well, do you remember chapter 5? Yeah, but I didn't quite get it then, and I don't. I just kind of, well, dude, sorry to tell you, you are now way behind. Okay? I'm throwing that right up front because every year it happens. So just please make sure you know how to factor. All right, with that being said, the reason we're factoring this chapter is to solve quadratic equations. So on that sheet I gave you on the way in, on the back of the note sheet, I actually have these steps. And I'm going to ask you to follow these steps today. Okay? First step, when we're solving quadratic, I want you to write it in standard form. Ax squared plus bx plus c equals 0. Okay? Now this is on there, so I'm not going to give you time to write all this stuff down. You can make little notes by it if you want. Okay? After you do that, the step that students forget, this is like the forgotten friend or something, man. Dude, look for the greatest common factor. Highlight that. If you have like Christmas lights you can put around it and decorate it, might be dangerous in your backpack, but do something that you can remember that. It's a big piece there. Some of you are going to forget that, and that makes your problem a whole lot easier. All right? The greatest common factor, by the way, would be like if I was giving you 8x squared plus 16x plus 6, I could take a 2 out of the 8, 16, and 6. 2 times 8, or 2 times 4x squared is 8x squared. 2 times 8x, 16x, and 2 times 3 is 6. Okay, so now I factored it. Okay, I've done a greatest common factor. Now what I need to do there is I still need to look at what's left over, the quadratic that's left over. Okay, so from that point, what I'm going to do is I'm going to take that quadratic that's left over, that 4x squared plus 8x plus 3, and I am going to factor it using what we call Lizzie's method. Now, you may know box method, you may know the string method, you may know all these different methods. I don't care really which method you use, as long as it works for you and it's efficient. It needs to be efficient, meaning it cannot take you forever to factor. You're like, well, I get there eventually. Okay, it can't take you that long. If you can't stay up with the class when we're working through problems, then it's not an efficient method. Okay, unless you just need a lot of practice with it. You need to get efficient at it. All right, so from there, first thing we do is multiply a by c. How many of you were here this summer? Okay, you should, we did this a lot, right? So hopefully this will make your life a lot easier.
I just love this.
Okay, A, B, and C. All right, we're going to multiply a by c. So I'm going to work through this one with you. A times c is 4 times 3, which is 12. All right, and I like to know whether or not that 12 is positive or negative. All right, so it's a positive 12. And I'm going to find all the factors of 12, all the things that multiply to make 12. So I'm going to do it in an organized fashion, like 1 times what is 12, so 1 times 12. 2 times what is 6. 3 times what is 4. Okay, and then notice if you do it in an organized way, then you go 1, 2, 3, 4. There's no 5, 6, 7, 8, 9, 10, 11, 12. Okay, you have all of them in a nice orderly fashion there. You have it organized, and that's what you want. Okay, you want to know that you've tried all numbers. Now 12 is an easy one because you only have 12 numbers to test. You've tested all of them by doing that. Okay, you get like 170 6, it's a little harder. Okay? What combo has the sum of b? So once you multiplied a and c, you want to find out which combo has the sum of b. Which of these add up to 8?
6 and 2.
6 and 2. So I'm going to turn my focus to 6 and 2. And if I'm actually working this problem without teaching it, I'm probably just doing 1 and 12 and testing it. Nope, doesn't add to 8. 2 and 6. Nope, that adds to 8, and I probably wouldn't even list 3 and 4. Okay, just because I already found them. So I have 2 times 6.
Can't see it.
Thank you. Okay, so 2 times 6. Those both add up to 8. They multiply to make 12. Okay. The next step is to divide by a and reduce. Once again, this is another forgotten thing. Divide by a and reduce. And I actually sometimes, these two steps, I kind of flip around a lot. You'll find there's things that you do that might help you out. But so when I divide by a is 4. I'm going to divide by 4. And I reduce 2/4 to make 1/2. And I reduce 6/4 to make 3/2. Okay. How many are with me? All right. Next step, set up your quantities. Okay, two things. This times this equals 0. If c in my original equation is negative, then my quantity should be a minus and a plus in my quantities. If c is positive and b is positive, then it's plus plus. And the reason that is because to get a positive c term, I'd have to multiply positive times positive. To get a negative c term, I'd have to go negative times positive. Right, if I'm doing FOIL. If c is positive and b is negative, then it's minus minus. Notice you could still get a positive c term if you go negative times negative. Okay, so what am I using in this one? I'm using, which one?
The middle.
Yeah, I'm using the middle here. So they're both positive. And I'm actually going to put my x's in. Okay, and then I have my 1/2 and 3/2. Now, the 1/2 is actually going to go here, and the 3/2 is going to go here. Okay, now really what I need to do from there to truly factor it, I need to bring the denominator out in front on each of these. So that gives me 2x plus 1 and 2x plus 3 equals 0. Okay. Any questions there? Yep.
So you just divide by multiply by the denominator by x.
Yeah, just bring that denominator right out in front of that x.
Ooh, you're off.
Yeah, I know. Hannah?
So you have to put the 2 in front of them.
The 2 and...
The original equation.
Yeah, and so at the I would have a 2 out here, yeah. The 2's not going to have any bearing on our problem anymore, though, but there would be a 2 out there. Symbols are correct. Solve for x. Now, if I'm solving for x, I'm going to take my 2x plus 1 and my 2x plus 3, which equals 0. And as Hannah pointed out, we have that 2 still hanging out here. The 2 has no bearing. We are multiplying 3 different things to make 0. We're multiplying 2. We're multiplying x plus 1, or 2x plus 1, and we're multiplying 2x plus 3. Those 3 factors, okay, those 3 things multiply to make 0. All right? So, if that's the case, when does 2 equal 0?
Never.
It never equals 0, right? If I'm going to multiply to make 0, one of these 3 things better be a 0. That's the only way you can multiply and make 0. 2 can never be 0, no matter how hard it tries. All right? You just can't make it. Sorry, dude. We don't care about you. All right. I know it's sad. All right? But when we're trying to solve, we're not caring about the 2. This part could become 0. 2x plus 1 could equal 0. When does it equal 0? Well, 2 steps involved to get it to 0. Those 2 steps are subtract 1. 2x equals negative 1. And then divide by 2. So let me zoom in here so we can see that. So we subtract 1 and then we divide by 2. So we end up with x equals negative 1/2. That's one solution. 2x plus 3 could also equal 0. There are 2 steps involved. What are the 2 steps? Subtract 3 and then
Divide by 2.
divide by 2. X equals negative 3/2. Now, if you can do those steps in your head, I expect you to do them in your head. Right? I expect that you could say, yeah, to solve this, I subtract 3, divide by 2, and that's my answer. Negative 3/2. Okay? I don't need to see you work that out every time. My solutions are x equals negative 3/2, negative 1/2. And notice I use the cool guy sets. Please understand, we trying to chunk all this together with what you've already learned this chapter. When you graph that, that means I can give you some points right here. I know that this opens up because a is positive. Okay, I know that it crosses my x-axis at negative 1/2, right there, and at negative 3/2. Okay, I know both those things. I actually know it crosses my my x-axis, or excuse me, my y-axis at
0. No.
at what? It's at 6, right? Okay, it's 2 times 3, right? Right up here at 6. I think I messed up on that last period. I think I told them 3. I think we were working on that. No one caught me. Okay. And then my parabola opens up. So it does something like that.
How do you get the bottom point down there?
Well, you could use opposite of b over 2a, right? I mean, I could do that real quick.
Oh, yeah.
Opposite of 16 over 2 times 8, like 1, negative 1. Okay? So we can figure that out as well. Yeah?
Does it matter what order they're in?
No, I usually go numerical, though. It doesn't matter. Okay? It's good to chunk things together because now that, like, if you can go, okay, yeah, that's how that relates to the first part, we're good. Okay, some of you are falling asleep and I'm 6 minutes off. So, all right, moving on. Here we go. Number 32. I want everyone to take a look at it. 32 on the mixed side. Solve each equation by factoring.
Oh my goodness.
Solve each equation by factoring. Here we go.
This is so fun.
This will be fun. I would suggest you're doing this on a note page or on your separate sheet of paper, whichever you want to there. All right. First step. Actually, you guys go ahead and get as far as you can on it. So, first step, we need to get it in standard form. 2x squared minus x minus 6 equals 0. How many made it that far? Very good. Next step is a times c. A times c, well, actually, greatest common factor, but we can't take one out, right? So don't forget to check that. A times c, 2 times negative 6 is negative 12. Okay, 2 things to multiply to make negative 12 and add to what?
Negative 1.
Negative 1, right? So I'm just going to be keeping that in mind as I'm going through. So when I go 1 by 12, well, I need one of these has to be negative. So really, if one's negative, it's kind of like I'm subtracting, right? Trying to find 2 numbers that differ by 1. Well, these don't differ by 1. Everyone get that?
Yeah.
Right? Like negative 1 and 12 is negative 11, and or excuse me, is 11, and then negative 12 and 1 is negative 11. So they differ by 11. Okay? Well, 2 by 6. Is there 1 between those? No. Okay, they don't differ by 1. If I subtract 2 from 6 or 6 from 2, it doesn't. Okay, how about 3 and 4?
Yeah.
Yeah. Okay, well, one of those has to be negative. I need more negatives in this case. These two have to add up to negative 1. So which one's negative?
4.
The 4 is. Okay, how many made it that far? Okay, so it's 3 by negative 4. Okay, any questions up to there? This is where if you're stuck or you're confused, you should really ask right now. Ask your neighbor if they get it. It's big. I don't want to go on. All right, we're golden?
We golden.
Okay, here we go. So from there, I'm using that. Next step is to divide by a, right? Well, what I really like to set up my quantities first. This is kind of where I vary a bit. I know that I'm going to use plus minus here. Everyone know why we're using plus minus?
Because C is negative.
C is negative, right. C is negative. So in order to get a negative, I'd have to multiply whatever goes here by whatever goes there, and that's positive times negative, right? Which gives me a negative. All right, so in this case, I also know that I have an x here. All right, I like to put in my numbers. I know the positive one goes there and the negative one goes there. It's just, what have I forgotten to do?
Divide by A.
Yeah, I haven't divided by a, right? Now, some students like to divide by a out here, kind of like we talked about it in our last example. Some like to divide by a in here. I don't care where you divide by a, as long as you divide by a. When I divide by a, this piece right here becomes, I can't reduce that, so the 2 moves out to the front. It becomes 2x plus 3. When I divide by a here, I can actually reduce this piece. What's it reduced to?
Negative 2.
To 2. Yeah. So nothing goes out, it just reduces. So now I have 2 terms, or excuse me, 2 factors multiplied together to make 0. If this one equals 0, 2x plus 3 equals 0, x has to be?
Negative.
What are the 2 steps in solving?
Divide by, subtract 3, divide by 2.
Subtract 3, divide by 2. By the way, how many of you got these quantities correct? Okay, good. Subtract 3, divide by 2. There's one solution. And this one, x minus 2 equals 0. Yeah, you just add 2, so x equals
2.
2. So my solutions are x equals negative 3 halves and 2. How many got that answer? Very good. Any questions? Yeah.
Wait, why is it x minus 2 in the parentheses? Because if you multiply the thing, wouldn't it be 2x minus 4?
But you got to reduce.
Reduce,
And if you put it as 2x minus 4, then you wouldn't multiply back out to this, right? You'd have 2x plus 3 and 2x minus 4. You couldn't. So your check when you're factoring, 2x times x is 2x squared. 3 times negative 2 is my negative 6. Yeah?
Does it matter where you put A and C when you plug it into the x, to the parentheses?
No. Other questions? How do you think you got it? Okay? I want you to try 35 if you haven't done so. If you have done so, just keep cranking through. How many are done with 35? Just curiosity. Okay, give everyone a shot there. Okay, how many made it that far?
Wouldn't it be minus 2 or plus 2?
Oh, shoot. All you that made it that far a minute ago, dude. I don't know what to tell you. Okay, A by C. A by C is 10. 5 times 2. 2 things to multiply to 10, add to 7. So definitely not 1 and 10. But 2 and 5 work. Okay, so if you want to divide before you put them in parentheses, you could. This is where you divide by A. So that gives me 5 and 5, and then I reduce. That becomes 1. So when I put it in parentheses, my parentheses this time are plus plus. I have my x. I have 2/5, so the 2 goes here and the 5 goes there. And then I have 1, so that's 1. And how many got the factored form correct?
Wouldn't it be 2x plus 5, not 5x plus 2?
And when you check, look, 5x times x is 5x squared. The other way you have 2x squared. The denominator drops into the front.
I got 2. Oh, okay.
So 2 steps in solving this one is subtract 5, divide by 2. That sets 5x equals 0. 5x plus 2 equals 0. Okay, that's where we'd subtract 5, divide by 2. And here, subtract 1. So we get x equals Negative 5/2 and negative 1. How many got it? All right. Yeah.
What should be negative 2/5?
Negative. Oh, 2/5. Man, I didn't even do that on purpose. Jeez. I'm making more and more of those mistakes. Okay, negative 2/5. Thank you for checking my work. I know, I guess. I know. Here's my question. A good question came up as I was walking around. We've talked about this graph, right? Trying to relate it to graphs. This would cross, where would it cross? Negative 1 and? Negative 2/5. Okay, so like there. All right, so this graph would do, you know, it would come down, hit there, and then jump back up. Something like that, okay? Is it possible for a parabola to never hit the x-axis? Yes. That means you couldn't factor it, right? I mean, if it won't hit, then you're not going to be able to factor it because you can't find solutions. Is it possible, so you could have the parabola doing this, right? It doesn't hit at all. Okay. Is it possible for the parabola to hit just once?
Yes.
Yeah, it could. It could come down and just hit there and jump right back up. How many solutions are there?
1.
That means you get 1 x equals. So you could get none, you can get 1, and you could get 2. All right. Yeah. Question? No? All right, you guys can skip 62 and 43.
Oh, I already did 62.
Good. If you did them, get extra credit.
62
Okay.
and 43.
62 and 43,
Oh,
skip
okay.
those two. Yep, you had to do those. Okay. So we've thrown this one out and that one out. I want you to take a look at it, this 1 through 15 right here, and just look at any of the problems that you're like, whoa, what do I do there? Or, hey, how's that work? Or, okay. Let me know if you see anything that you're a bit confused on. Maddie. Number 4. Oh, I'm glad someone asked it. All right, number 4. Number 4, how many terms?
2.
2 terms. You love 2 terms. When you see only 2 terms in a quadratic, you're like jumping for joy, man.
We're jumping for joy?
Yeah, unless you have a hurt leg. Okay? Then you shouldn't.
That's me.
Yes.
If you get the same answer, like if both points are -2, so that's still okay.
That's one answer. The answer is -2. Yeah. Okay, so everyone's taking a look at number 4. There's only 2 terms. We still want to get it in standard form. So subtract 6x, right? X squared minus 6x equals 0. Only 2 terms here, man. You're going to have to memorize it. Like 2 terms. You love life with only 2 terms. Okay? Now, what's the second thing you always do in solving quadratics?
Look for a greatest common
A times
factor.
C.
It's not A times C. All of you have already forgot except for Jordan.
Common factor.
Greatest common factor. What comes out of x squared and 6x?
X.
And x. X times what's x squared?
X.
X times what's 6x?
6.
6, and it's -6, right? Notice you're factored now.
Yay.
Dude, you love 2 terms, right? If this,
2 times.
so that times that has to equal 0. That means one of these is 0. What makes x 0?
0.
Not a trick question.
If X is 0.
If x is 0, okay? What makes that 0? 6. Those are my solutions. You love 2 terms. You're like, yeah, man. Woo! Dude,
2 terms.
you'd be like writing it on your binders and stuff. You're like, 2 terms.
Picture 2 chains.
Okay, any others that you look at there and you're like, hey, what do I do?
All of them.
10. Look at 10.
Oh, yes, there's no B.
Hold on. There's no B, but there is a
C.
there is a C, and there's how many terms?
Hey,
Hey, 2 terms.
that's so nifty.
2 terms.
2 times.
Yeah, man. 2 terms. Hey, and this one's even better because B be the problem. We hate B because then we have to factor. We don't even have to factor this one because there's only one x we see.
Plus 4.
Add 4. X squared equals 4. What's x? X is almost 2.
Plus or minus 2.
Plus minus 2. Take the square root of both sides. You imposed it.
Ciao.
Okay, so x equals plus minus root 4, which is 2. Plus minus 2. 2 terms. Hey, we love 2 terms.
That's radical.
That is radical.
Be like.